So today what we're going to do is we are going to be working on systems of equations, word problems. And today is the 4th. Okay. So here is example 1. Neil has a total of 12 $5 and $10 bills in his wallet. He has 5 times as many $10 bills as $5 bills. How many of each does he have? Okay, so that is our first example. Now, as you all know, when we are writing equations to go with word problems, the first thing that I should be doing is defining my variables. So here I have let x equal and let y equal. Now, it doesn't matter which item I assign to which variable. That part doesn't matter as long as I define my variables. So for me, I'm going to say let x equal $5 bill. And I'm going to let y equal my $10 bill. And then when I read through this, I could pick out that there was one total for sure. And the total that I was able to pick out was that he had a total of 12 bills. As I was reading through this, I did not identify another total. So I'm going to leave it like this for now. If you recall back to an earlier lesson we did, when we worked on this, we used a standard form equation, ax plus by equals c. And then basically we set it equal to the total and our two variables. So in this case, that's what we're going to do with this information. I have my $5 bills plus my $10 bills, and that equaled a total of 12 bills. Okay, we got that. Now, this is the part that in this problem is particularly tricky because I have to come up with equation number 2. So this sentence here, he has 5 times as many $10 bills as $5 bills. That sentence there is the other sentence I'm going to need to use in order to write my second equation. So he has 5 times as many $10 bills as $5 bills. So when I read that, I'm reading that he has more $10 bills. So I'm going to choose to set that equal to y, because y is my $10 bills. He has more of those. That's what I'm reading. So he has 5 times as many $10 bills as $5 bills. So he has 5 times the amount of $5 bills equal to his $10 bills. So those are my 2 equations that I end up being able to write. Now, oh, sorry, that got crazy. this is set equal to y already, which means I don't need to set one of my equations equal to a variable, which means I can just go ahead and substitute at this point. So I have x plus y equals 12. I have x plus, I'm substituting 5x for y equals 12. This makes 6x equal to 12. Divide by 6, divide by 6, x equals 2. Then I'm going to come back here and I have 5x equals y. I'm going to substitute x because I'm trying to solve for y. So I have 5, substitute my x equals y, 10 equals y. So my ordered pair here, my solution is 2, 10. And then when I think about what this says, does this add to be a total of 12? Yes. Is 10 5 times as much as 2? Yes. So it meets all the criteria. Now, the only thing I need to finish with is the fact that this is a word problem, and I need to represent my answer in a sentence, a complete sentence. Capital letters, period at the end, complete sentence. So the question is asking me how many of each does he have? So I need to write down that Neil has 2 $5 bills and 10 $10 bills in his wallet. Okay, so that is example number 1. Pretty straightforward. We're setting up our 2 equations. We're defining our variables. Answer should be in a sentence. This should feel review-like. Okay, so example number 2. Okay, so example number 2, Winston drove a total of 248 miles on Monday. Ooh, he drove 70 fewer miles in the morning than he did in the afternoon. How many miles did he drive in the afternoon? Okay, so there's my word problem. So the 2 things that I'm comparing are the 2 times that he's driving. So I have let x equal, I'm going to just say let x equal morning miles. And then I'm going to have let y equal afternoon miles. And then I'm going to go back and I'm going to look for my totals. So one of the totals I think is really spelled out. So I have one total, which is 248 miles. And then I have a second total. Now this total is a little bit less obvious, but it goes along with what I'm solving for. So what I'm solving for, my final question was, how many miles did you drive in the afternoon? So this total is going to be number of afternoon miles. Because that's the second equation that I need to set up. I need to have it equal to the number of afternoon miles. So I'm going to move this up a smidge. I start off with my morning miles and my afternoon miles equaling a total of 248 miles. Now we just talked about my second total being afternoon miles because I'm trying to solve for afternoon miles. So I'm going to start by setting this equation equal to afternoon miles. Then I'm going to go back and reread. It says that he drove 70 fewer miles in the morning than in the afternoon. So that means I have morning miles plus 70 extra miles equaling my afternoon miles. Now, some of you might have read that differently, where it says 70 fewer miles in the morning than he did in the afternoon. So I have afternoon minus 70 equals morning. Okay, realistically, these are the same thing. So if you had read it and it makes more sense this way, that's okay. These are the same equation. They're equivalent. So that part doesn't matter that much. Now what we're going to do is we're going to go ahead and start to solve. You can see this is already set equal to a variable. So all I need to do is substitute. So here I have x plus y equals 248. X plus 70 equals 248. 2x plus 70 equals 248. Minus 70 minus 70. 2x equals 178. Divide by 2, x equals 89. And then I can come back here and I could say x plus 70 equals y. Substitute the 89 plus 70 equals y. This is 159 equals y. So I have this and this here. I'm going to have to move back up here to write. My apologies. So this is 89, 159. That's my solution. And then I need to write a sentence. The question is asking how many miles did he drive in the afternoon? My y represents afternoon miles. So Winston drove 159 miles in the afternoon. And there you have it. We're done. So this right here is solving systems of equations that are word problems. So we're going to be writing 2 equations. You need to define your variables, write your 2 equations, substitute, solve, write a complete sentence as an answer. That's what we're working on.